Alright, so we looking at the EtherCAT. So it's just a basic EtherCAT introduction. So we look at the overview of EtherCAT, the interfacing and fault finding, some suggestion and question. So EtherCAT basically is an Ethernet field bus. So overview on what is it. So this is a sort of like a traditional analog system. So you have the field inputs and outputs like IOs using CAN opens going to the controller, and you have the servo. From the controller you're feeding the analog voltage to the servo drive, all these. So if you look there's nothing wrong with the system, but you know there's a lot of cablings and so many things that can go wrong, electromagnetic interference and stuff like that, right? So in the EtherCAT system, so everything is sent through the EtherCAT telegram. So you have only one motion controller, and all the servo drives and IOs are connected via this, are called as slaves. So they are just connected via the EtherCAT network. So it's more easy, it's not messy, alright? So it's easy to debug. Yeah. So high speed, so it's deterministic, it's precisely synchronized, low cost, and it's flexible. Alright, so this is just a slide showing what is the key benefits, which is already discussed before. So basically it's the ease of use. If you are using, if you have familiarized yourself with this controller, if you are using the EtherCAT, it's more simple because it's just one cable. Alright, so if you see the cable is already done, you are wiring up the servo yourself. You are wasting a lot of time to do that. Yeah. Yes, the faster the machine build and commissioning timing. So that's what I say. Less wiring, better diagnostics, right? So you reduce all those stuff. More efficient machine design, greater throughput and less waste. Like what I showed to you, it's making the architecture more smaller. Alright, reducing maintenance costs. Alright, better status data, low cost, flexible topology. So you can have several topology you want. You can have ring, yeah, all sort of topologies. So easily you can extend your network from a legacy controller to an EtherCAT. You can easily extend it. So yeah, wide vendor support and diverse slave types. Alright, so the thing about EtherCAT is if you are you can have the slave devices, right? So the EtherCAT technology is from Germany, from Backoff, originated from Backoff, right? So you can have you can create an EtherCAT slave, all this. But if you are a master, you have to pay some fees to Backoff, right? Yeah. So that's the thing. So there are so many slaves devices in the market. So there are EtherCAT stepper drives, EtherCAT servo drives, EtherCAT IO devices, EtherCAT thermocouplers, so on. So encoders as well, yeah.
So no license on slaves, but license for masters. So
yes, which I would say that is very convenient, because you only going to have one master, but the slaves are the one that. Yes, so that's why it's getting more and more popular. So, but maybe Jeff can explain. When Trio decided to adopt EtherCAT, so they were actually exploring what is the factory communication protocol that they want, automation communication protocol that they want to adopt, and everyone decided to go with EtherCAT is because of all these benefits that they foresee. Yeah. So I know, like you're talking about CAN open, right? So there are, even if it's CAN open, everything is fine, but if you talk about in terms of wiring and stuff like that, I think this is more flexible, and going forward in the future, so everything is going to be more faster. So at one point people start thinking that you will be contracted to them forever, right? If they are not developing anything, if one day they say, okay, we are going to stop using art, we stop going to develop artifacts, so what the factory is going to do, right?
Another reason is sometimes that some projects, they need to use some special devices. Like encoder,
yeah,
like safety devices, and they all are developed over EtherCAT. So if they don't have EtherCAT or they didn't think about it, so they're
gonna go out of
on the project. Exactly. So that is why the EtherCAT getting more and more popular, because many manufacturers just goes in that way.
Yeah, this slide need to be updated. So the 4N is no longer, it will be obsolete next year. So it's replaced with the 6N, which is more powerful. Yeah. So the 4N was like sort of the first generation EtherCAT controller that Trio came up. So how does EtherCAT achieve high speed and deterministic timing over Ethernet? So this is just it uses the physical layer, alright, and it's not using CSMACD, which means collision detection. So it's just like it's sending up telegram and then it's receiving back. In Ethernet there are some collision detection, so it has to be broadcast and then it has to make sure that the telegram come to the right sender back. Yes. Yeah, so sort of this. So master sends the single telegram. So you have full duplex cabling, so high bandwidth utilization, very small delays in the slaves. So you can have we call it Ethernet on the fly, or so if you want to look at another analogy, the EtherCAT is like a fast moving train where the passengers just get down wherever they need to. If you think of that, so then you can understand the whole EtherCAT. Alright, yeah, so this is an analogy of that. Yeah, you can see that the process data is just extracted and inserted on the fly. So it's high speed handled by the hardware EtherCAT slave controller, so that's called the ESC. So there's a slave chip in all this and it's controlled by this chip. So telegram is processed, not affected by the slave processor performance. So your data transfer doesn't matter if your slave processor is slower, but your data transfer is still using the EtherCAT. So it will still work as how the standard Ethernet works, right? So process data of any size per slave almost unlimited. Also format of process data can be defined by application layer protocol. So and then an additional one, there's an asynchronous event triggered communication. Is the mailbox, which is included in Telegram. So you have two types of data transfer. One is the synchronous, which is cyclic, alright, it's done to the EtherCAT server period, and another one is asynchronous, meaning you can request some information from the slave and then you can provide. Alright, so that can be included in the mailbox when it's transferring the data. So this is what we talk about, the precise synchronization, which is lower than 1 microsecond by the adjustment of distributed clocks. So what it does is, the masters, when you are activating a EtherCAT network, the master will tell, there are 4 states of EtherCAT. So the initialization state will tell me that I'm on this clock, alright. Then it will send all the slaves through this switch, so it will know the position of each slave by the position of the cables. So when the data is sent over, the delay is always in a fixed delay. So the slave knows that I'm in position 1, I'm in position 2, so this is the time I should receive the telegram, this is the time I should send back the telegram. Alright, so that is the precise synchronization. So the term there we use is the distributed clocks. Okay. So this is talk about flexible topology, so you can have a ring network, so the data can flow back to you. So if there is any cut in the network, so your system will still be active. Yeah, this is about the topology, right? So it can be extendable. That's the beautiful of this, is you can extend to how many slaves you want. So you can have 4 masters, then you can have redundancy as well. So if you see here, so this is connected, then there's another cable going back to the master. If there is any disconnect between this, it can still send a telegram back to. Alright, so you can have your own. So if you look at this, the HMI, and this is also extending to the factory network as well. Alright, so well, they say it's 65 nodes for each EtherCAT segment, but that is just a way of. Well, this slides was made by Backoff, so obviously, so everything has a limitations, and it depends on how much data you send over the channel and how many nodes you have, right? So yeah. So this is a example of Backoff, where they have 10,000 nodes on a EtherCAT system, and the thing is, the data is sending faster than the analog way. So alright, so this slide actually explaining how the EtherCAT works in trio way. So we used to exchange data, and then it's called the protocol that we use is CAN over EtherCAT. Alright, so all these objects which you see are CAN open objects, each represent a functions in a CAN open library. Alright, so the 6040 means control word, and you have the target velocity and the modes of operation, stuff like that. And if you look at this, the process data info, so this is what we're going to map to the slaves. Alright, and yeah, it's called PDO, and these are the data that will be sent cyclically. Okay, so you can see that there is this index and sub-index, and you have to define all the bit lengths that is sending through, so it knows that what is the data that is sent through, and this is what it's expecting and what to read back. And then this is that was the RX PDO, and this is a transmit PDO, so what you are sending back to the controller. This is just a slide showing how you can integrate all this into this. So you have encoders, you have server drives, you have IOs, and so a typical EtherCAT master will use the following procedure to create a network configuration. So there is a file called ESI file. It's the EtherCAT slave information. So every slave manufacturer will have this file. So the one more interesting thing about Trio is it doesn't matter what EtherCAT slave you are using, we're able to communicate with that, because we take this ESI file and we extract this, and then we just put in the information that the Trio requires inside. So we call it an EC extend file. So we create for this. In our database there are hundreds of EtherCAT slaves, but then there are still hundreds of EtherCAT slaves being produced, right? So it's not updated. So if you have some new devices, we can just create an extension file and add it into your network. Yeah, that's why I say startup is plug and play. So you have all these server drives lined up, all is using, so you can start up the network as fast as possible. So now I have a controller connected to the EtherCAT network. So you still use the same motion perfect, right? But you use this intelligent drives configuration. So if you click on that, obviously you don't have anything connected right now. You will see here there's a, and I like this because it really gives a graphical interface sort of feel. So it says now I have my controller connected to 3 axes of drive, which is Aston Pronet drives. It shows the pictures, alright, and this is on axis 1, axis 0 and 1 and 2. What are the address? Everything is given here. Okay, so I can change. Just now I showed you the 4 stages of EtherCAT. So you have initialization state, pre-op, safe op, and operational. So if you just have a controller and wire it up to a drives, right? So what is the first stage you do is you go to terminal 0 and just type in this command, EtherCAT 00. What it does is it will reset the EtherCAT network, it will find for the new slaves, alright? And this will actually set all the states here, and will also give information on whether it's in operational state or pre-op state, and if it's in pre-op, why it's in pre-op, it will tell you. So now over here it says it's in operational, and then the configuration will tell me what are the drives that is connected, okay, and in which axis it is, which switch position is that. Alright, so I know which exactly what axis is which drive. Similarly, you can do that from here, and if you click on the controller port, so this will collect any diagnostic info and then let us know what is wrong with the device. Okay, so if I do an X, so it will generate a report to us, and then it will actually, in this format, now you can see it says there's no current system error, there's nothing, it just says my server period, what is that, and it will tell you actually what is the axis, what is the vendor ID that is connected, and so basically this is setting all the address up and telling you what is the information being exchanged. So if when after you put in all the information you have an error, for example, so you just click on this and then you generate the report and send it to us, so we can debug what is the problem, then we can explain to you why it's having this problem probably. So let's say if I put this in init, alright, now I click this, generate report. So now it's saying my remote device has reported an error, okay, so my drive is not responding, and then why is that? So if you check on that, so all these error flag has been set up. Oh no, the error flag was there, it's an error log. So you can see all the data are 0, so there are no data being exchanged, because in initialization mode it will just set up the data need to be sent, but it's not sent yet, so it's just setting up the table. So these are the information that I need to be sent. So but you can see that the MDP configuration, this is the manufacturer's device profile, so all these are saying value unavailable because there's no information exchange in the init stage. So from init to pre-op, it will start exchanging some information saying that I am this device, okay, are you ready, and stuff like that. So if you click on this, it should give you a so now it's saying there's no system error, but I am in pre-op, so something is, so I still haven't received any data. So let's look back. So now you can see the difference. Now you have all this mapped inside, right, but it's still not ready to talk until I reach the operational state where you can enable the drive. So you can set from here itself, but if the stages are not really oops, shouldn't have done that. You can do it from here itself. So this will,
it's exactly the same as
yeah.
EtherCAT 00.
So that button is actually the EtherCAT 00. So it does. It's doing again. So that's why they say it's plug and play. Obviously it's plug and play because now I have the EtherCAT slave information of these drives in the controller.
Yeah.
But if you have a drive where I don't have the information, then you have to send it
Send
as
that
a
file.
for us to take it as an ECX thing. So if you click on the drive, it will give you the status, alright, what is the position, the alias, address, yeah, your controller, what is your position, so what is your control word, your status word, and here it will give you the can open object, so the equivalent. So 607A is talking about the target position, and 664 is the actual position. And you can click on this, it shows the same thing. So that is for on the EtherCAT part. If you have a FlexSys devices control, so this is not only for server drives, you can extend to any type of slave. So you can have an encoder, you can have an IO devices, whatever. It will just line up. Only the information that need to be mapped to CAT will be different. Like here, obviously it's a server drive, you need position. For my IO devices, that's something else that you need to have. So need that other things that is different. Yes, so I think that's all about on the EtherCAT side. Any questions?